Right, I think it's a privilege for us to hear from Rob. So without further ado, Rob, I'd like to invite you on stage.
Nice. So this is, I'm live. Great. I tell you, I am definitely going to post the slides on my site tonight. And I will open every file inside the .git folder. But here's the part where I tell you I will definitely post my slides tonight. There are no slides. It is only live demos. That is so much of web pages. And in case you want to view those web pages later, that includes all of those details. So to get rich.org, click on presentations here, dive into the .git folder. You can get at the list of resources. Well, you're here on robrich.org. Thanks for the introduction. Let's click on a button recently. Yep, my Microsoft MVP, Redgate. I'm a Cyral developer advocate, so if you're struggling, you can't hear me? The video things.
Hi everyone, just hold on a while we diagnose some technical issues with Rob's.
Can you hear me now? Oh, cool. Should I try turning my camera back on, or are we just like this? It's not like we're trying to move bits across the world. Oh wait, that's exactly what we're doing. Okay, so thanks for the introduction. Here's the part where I tell you I am definitely going to post the slides on my site tonight. But in this talk, there are no slides. We're going to dive into the .git folder, and we will examine every file in there. Thanks for the introduction. Here's a little bit more about me. You can head to robrich.org to learn about it. AZ GiveCamp is one of the things that's particularly cool. AZ GiveCamp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver the completed software to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp here in Singapore or wherever you're watching from, hit me up on email or Twitter, and let's get a GiveCamp in your neighborhood too. Some of the other things that I've done, I do a lot of Docker and Kubernetes training and consulting. So if you have that need, hit me up. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air and they sent me a mug. Woohoo! So there's my claim to fame. So let's dig in. Now, right now we just have an empty folder. So let's create a new Git repository. Now we could definitely say git clone https github.com hub.com/foo, but in this case, let's say git init. Now we've got a Git repository. And if we do a directory, we don't see anything. But if we do an ls-la, we ls-l, nope. If we do a deep directory, then we will see this .git folder. Now I happen to have shown hidden files here. I went into view options and showed hidden files. But on Mac and Windows, it is hidden by default because it is a dot directory. So you'll have to do ls-la. But apparently that doesn't work inside PowerShell. Now that we've got a Git directory, let's add some content into it. Actually, before I do that, let me open up this Git directory in PowerShell or in VS Code. Now, I'm specifically opening up the .git directory and not the containing directory because VS Code will hide the .git directory for us, which is pretty cool. So we have head, description, config, refs. We've got that one pretty empty. Objects, we also have some empty directories in there. Info, hooks. Now we're going to dive into each of these files in time. First, let's take a look at objects. Now, yeah, definitely. This one is definitely bigger, but VS Code's left menu is a little weird. Okay, file one contents. I'm going to redirect that to file one, and then I'm going to git add file one and git commit -m file one. Oh, let me give it a message. File one commit message. There we go. So we've got our first commit. And now here inside the .git folder, we have Control+. We have three folders here. The AD folder, the B8 folder, the F3 folder. We've got three files, one inside of each one. If we were to say git log, we see this commit B843F4. Okay, so here inside the .git folder, here's B843F4. And if we open that one up in text editor, yep, it's binary. It's a whole bunch of garbage here. So let's take a look at it. It is actually zlib compressed. So we can take a look here at ways that we can unzlib compress this. Now we could use Perl, we could use OpenSSL, an interesting use of OpenSSL, by the way. We could use Python. In this case, I chose to make this node program. Here is the node program. I just called it unzipper. And unzipper, oh wow, that's big. Unzipper will go read the files and unzlib compress it using this inflate function from the zlib directory, library rather, and then split it based on nulls and output it. So let's take a look at that. We've got B843, so let's say unzipper.git/objects/B8/ and here's the contents, pardon me, here's the contents of that file. It says commit 194. We've got some content that looks a whole lot like the commit message. Yep, here's that file one commit message. We've got the author and committer, email address, date and time here. Yep, so this commit is that commit message, and it references this, AD88CA. Well, that looks familiar. Here is AD88CA. Now that's also a zlib compressed thing, so let's unzipper that one. Git/objects/AD, and that one, it's double zlib compressed. That's interesting, but it says tree and 37. Let's take a look at the third one as well. So AD88, we've also got F3CF. Okay, so let's unzipper F3 and CF. And so here's the contents there of that file. Now it says blob, and here's the file one contents. Ooh, that's the contents of the file that we created. So we see three different types of nodes. We have commit nodes, we have tree nodes, and we have blob nodes. Now we could definitely unzipper them, but this one being extra compressed, that's a little weird. Instead, let's use Git commands for this. So git log, we'll first look at B843. We can use git cat file -t, and it will tell us the type of that node. Now we saw before it said commit 190 something. It's a type commit node. Now if we cat the contents, we can use the same command, but we'll say -p instead. And here's that content. When we unzippered the file, it said commit and then it said a number, and that was the length of this file. That's cool. So we've got that. Let's also git cat file, and we'll do the type of this tree node. It's going to tell us, yep, it's a tree node. Let's do that, but let's actually grab the contents. And now we see, oh, hey, here's some file permissions. Here's a blob node, and we'll reference this one. Oh, that's the third node. Nice. Git cat file -t. It is of type blob. Git cat file -p, and we can see the contents of that blob. So let's commit some more stuff. We currently only have one file. Let's say echo file2, and we'll redirect that to file2.txt. Do we have any more files here inside of our objects folder? Nope, not yet. Okay, let's git add file2. Do we have more objects yet? Yes, we have the 6C folder. That's cool. Now let's commit it. Git commit -m file2, and now we've got a new commit, 545D. So back in here, here's 545D, and we also have this tree node in the middle. Now let's take a look at that 545D. Git cat file -p 545D. Notice that I don't need the whole commit, only just the beginning. And that references this parent node and also this tree node. Keeping track of this is kind of getting a little bit confusing. I'd love to have a tool that will help me visualize this. Well, I've built a tool here at Git Explorer. That's in the list of tools on this gist. And this allows us to be able to visualize the content. We'll start off by putting the path to our repository, not the .git folder, but rather the folder that contains the .git folder. So let's start up that website here. And, oh, looks like it's already started. Let me start it again, just in case. Pardon me. And now when we've got that folder, that content running, let's take a look at this, and we'll be able to see the content inside of our repository. Oh, it's still building. Okay, there we go. Now we'll see those 6 nodes, and I can click on each one and it'll show me, oh, there's the blob one. Here's the tree node. Here's, well, wouldn't it be cool if we could show the types? Okay, so now I can see the types, and I just randomly picked colors for them. And now let's show their tags. Well, that's a little bit weird. Let's put them in alphabetical order, and now we can show their tags. Okay, so F3CF, B843. Now we can much more easily cruise through them. But as we were looking at this node, we saw that it had a parent of this one, so we could then go reference that. Wouldn't it be cool if we could, I don't know, put them in order? So let's flip to the parent-child view. We'll show the lines and show the tags. And so here's that commit that we just made, and its parent commit is right here. This commit references this tree node, and this tree node says I have 2 files in the working directory. And so here's the first file, F3, and that's right here. The second file, C6, and that's right here. So in this original commit, we only had 1 file in our checkout directory. In this new commit, we have 2 files in our directory. That's cool. Let's create some more commits. So I'm going to come in here and I'm going to say echo file3 and redirect that to file3.txt. Do we have any nodes, any new nodes in our thing? Nope, we've still got just those 6. Okay, so now let's git add file3 to our staging area. And we'll come in here and refresh. And we saw it create that new commit. Let's show type, parent child, show the lines, show the tags, and we have this new blob node. As we add content to the staging area, it creates this new blob node, and that's really helpful to be able to keep track of the portions of that file that we've chosen to commit. Okay, now let's commit it. Git commit -m file3, and now we've got a new commit. Let's refresh this, show the type, parent child, show the lines, show the tags. Okay, here's our new commit. It references this tree node that says there's now 3 files in this directory, but we still only have those 3 blobs. That's cool. Here's file 3. Now, that was cool. It created the blob as we added it to the staging area. It created the tree node and the commit node as we committed it. Well, what if we create something in a folder? Let's come here into this Git folder and we'll create a new folder. We'll call that folder. And now I'm going to say echo file2 and redirect that into folder/file2. Okay, let's git add folder/file2, git commit-m file2 in a folder, and let's take a look at what those nodes look like. Refresh, show type, parent child, show the lines, show the tags. Ooh, here is our commit, and it references this tree node, and this tree node says I've got 3 files in the current directory and 1 file that is in this folder. Now notice this is 6C49, it's this file 2 right here. We still only have 3 blobs, even though we have 4 files in our working directory, because this file is exactly the same. We don't need to re-add the blob, and because these are zlib compressed, and because Git is so good at reusing content, then it's really cool. We didn't need to take up extra space just because we wanted to keep track of more content. Now that's awesome. Here in our objects folder, we have those objects for commit nodes, we have tree nodes, and we have blob nodes. Now, if we were to run git gc, it would pack them into this pack folder, but I'm not going to do that right now, just so that we can start to explore them in interesting ways. Okay, so that's objects. That's how it stores things inside of our repository. Now, one of the things that we notice here is we have git log --one line --graph --decorate. We have labels. So here's head and here's main. Let's take a look at that. Now here in this folder, we had a head. Oh, that's interesting. Let's open up head, and it says ref to refs heads main. Okay. Now where is refs heads main? Well, we do have a refs folder here. Let's pop it open. Oh, there's a heads folder inside, and here's main. FB3E06. Oh, that looks familiar. That's the commit that it's on. So if I wanted to move my main to, I don't know, right here, then I could actually, let me say git log. I do need the full commit for this. If I wanted to move it to this commit, I could put this commit here in this file, and now git log --one line --graph --decorate. Decorate is the one that puts the labels on. Now head is pointing to main, and main is back down here. Now, the only way that we can break Git is by changing content in the .git folder, so let me put it back there. But we can see that refs heads main is the location, the commit that this points to. And head is the spot where head points to. So if we were to say git checkout, let's create a branch. Git branch, branch 2, and we'll put it here on this file 2. Oops. Branch 2, there we go. Now we have 2 branches. Head is pointing at main and branch 2. So back in our .git folder, we see we have this new branch 2 file that points at a different commit. Now head is still pointing at refs heads main, but if we say git checkout branch 2, now head is pointing at refs heads branch 2. That's cool. Now, if we, for example, say check out this, so let's say git checkout this commit. Now we're not checking out a branch, we're checking out a commit. You're in a detached head state. Did I just take off my head? I imagine Halloween zombie things happening. Now what it's telling us here is that head no longer points at one of these branches, it just points directly at a commit. Now we can still use Git. We can still say echo file 5, redirect that to file 5.txt, git add file 5, git commit -m file 5, and that still worked. Let's do git log --one line --graph decorate, but we're also going to do --all to be able to see all the branches. We can see that this one went this way and this one went that way. Now that's okay, but because we don't have a branch label here, eventually as Git goes and collects unnecessary nodes, it might reclaim this one. What the zombie message here is telling us is that we need to check out a branch. Okay, so let's say git checkout -b branch 2. Oh, not branch 2, branch 3. There. Now Git is a lot happier because head now points at a particular branch. Head no longer points at a commit. Great. So we got to see how refs heads work. Here are the branches that we have. Well, how do tags work? So let's do our git log --one line --graph decorate -all, and let's put a tag here on main. Git tag v0.1 main. Now we've got a tag that matches main. So let's open up that tag. Inside refs, we also have this tags folder. Here's v0.1, and here's that commit, which, yes, thanks VS Code. I'm glad you have things that'll help me with .1. FB3E06, which, by the way, is that commit message, FB3E06. So the tag doesn't point at a branch, the tag points at a commit. The branch doesn't point at a tag, the branch points at a commit. So that's pretty cool. Now, we saw how we could use heads and tags. How about remotes? Well, I happen to have this other folder here, this server folder, and it is also empty. Let's switch over into that server folder, and we will say git init. We're going to build a server. Now, in this case, for servers, we probably don't need that checkout directory. So we're going to say --bear. Now, by saying bear, we don't create the .git folder and its contents. Instead, we just create the contents. So I don't have a .git folder. I only have the contents of the .git folder, which means I have no checkout directory. That's perfect for a server. So I've got this server here. Now, I want to be able to reference the server from my branch, and so I could say git remote add origin. Why is it called origin? Doesn't need to be. I could call it server or AWS or Azure, but by default, we call it origin. And then I'll give it the URL to that. We could say https github.com/ blah, 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 or we could point it to a file server, server/path to repo, or we could say a file on our directory, on our local machine. So c git path to repo. But in this case, I'm going to say it's up one directory and inside server. Cool. Git remote -v will list the remotes, and so there's our remote. Okay. So now let's say git push origin main. Now it always bothered me, why do we specify the server first in main? Wouldn't I want to say git push the main branch to the origin server? Well, yeah, but I could push to the origin server the main branch and branch 1, branch 2, and branch 3, and those would all go together. And so I need to specify the server first because everything else is a branch. Okay, so let's push main and branch 2. Now the cool part is if we pop over to the server and we look inside the objects directory, it now has all of those objects in the same way that our local machine had those objects. Perfect. Now let's pop back into VS and take a look at the refs. Now we have here a new folder called remotes. Now inside the remotes folder is an origin folder, and inside the origin folder we have main and branch 2. Here's where we left the server last at 545D78 for branch 2 and FB3E06 for main. Perfect. Now, if we were to say git push origin branch 3, now we would send these additional things to the server. It now has more objects in its objects folder. And back here on our local repository, we now have a reference to branch 3 as well. So that's cool. Here in the refs folder, we have all of the heads, all of the branches, all of the remotes, all of the tags, all of the human readable pieces here in the refs folder. Now they all relate to various commits that we have in the objects folder, and head is one of the refs. Why is it not in the refs folder? Because Linus said so. Okay, so I've got this content here, and git log dash dash one line dash dash graph dash dash decorate dash dash all. I'm going to say git remote remove origin. Now I don't have any of those red branches. That's cool. Now I'm going to say git checkout main, and I'm going to say git branch dash d branch 3. I am totally done with that. Oh wait, no, I'm not. Now how do I get back to that content? It's gone. Well, is it gone? Let's come refresh our graph and take a look. Show the type, parent child, show the lines, show the tags. Here's where main is. Here's where that branch was, but there's no branch pointing to it. It's still there. Now it's E886EB, but let's see if we can find that. Our next tool that we're going to look at is Git Reflog. Sometimes I see this said as Reflog, and I can see this cat of nine tails. It's like, yeah, that's not it. Reflog. We're looking for where did the refs move? Now, we didn't specify anything, so it's going to look at head, and it says head was here, and it moved to here. It was here, and it moved to here. We can take a look here inside the .git folder, in the logs folder, and we will see that log of where all the content was. So we were here, and then we moved to here. We were here, and then we moved to here. So reflog is a great way to be able to parse this content. And we have reflogs for every head and every remote that we need to look at. So we did a reflog, and we say, we used to be right here. That's cool. Git checkout that. Git checkout dash B branch 3. And now if we do a git log dash dash one line dash dash graph dash dash decorate dash dash all, we're back. Reflog is a great way to be able to find the content that you've built recently. Now let's do one more thing. I want to say echo file 6 and redirect that to file 6.txt. But here in file 6, I am going to accidentally commit some content that I don't expect. Here's some accidental secrets. Git add file 6, git commit -m file 6. And now I'm cruising through the repository, looking at my content. Let's show the type, parent, child, show the lines, show the tags. Uh-oh, I committed some secrets. Here's my accidental secrets. Let's see if we can remove them. Now I'm going to come into the file, and I'm going to pop this open, and I'm going to delete that line. And now as I commit my content, git add file 6, I know that there's a commit flag that I can use. I'm going to say --amend. Now amend is kind of like automatically squashing this into place. So I'm going to change this commit. Git log --one line graph decorate all, and yay, it's gone. It's out of my local directory. It's out of my commit history, but is it? Let's refresh this and take a look. show the type, parent child, show the lines, show the tags. Here is our new commit, and it references this tree node that references this blob, and we see file 6 without the secrets. But we still have this commit right here that references this blob that does have the secrets. If ever you commit secrets into Git, Git is really good at keeping track of them. So the moment that you commit secrets into Git, even if you squash them out, even if you force push, consider those secrets lost. They are already in Git's history. Now, we did a bunch of stuff. Eventually, it'll fall out. If we run a git gc, then if it's been older than 2 weeks and if it's no longer referenced, it might fall out. But how many people cloned this repository and got that commit before we did this? The moment that you commit secrets, consider them lost. Now we took a look at the refs folder. We took a look at the objects folder. We took a look at the logs folder. Let's take a look at hooks. Now each of these hooks is a shell script. Now it ends in .sample, so these aren't running yet. Here's a Perl script, which is pretty cool. But if we were to rename these and remove the .sample, then they would execute. So let me reach into this folder. I've got a copy of these hooks files with the .sample removed, where in each one, I am just echoing the hook name and the arguments that got passed to it. So here's my commit message hook, and here's my fs monitor hook, and here's my post update hook. So now let's do some operations and see how hooks work. Hooks are great for being able to do automation, like let me go run unit tests on the files that changed, or let me go lint the files that I'm about to commit. So echo file 7, let's redirect that to file 7.txt. Nope, no hooks have run yet. Git add file 7. No hooks there either. Git commit -m file 7. And now we see a pre-commit hook, a prepare message hook, commit message hook, and we can see the arguments passed into it. So, for example, that's the name of the file that contains this message. If I wanted to manipulate that, I could change this file, and then when it came to committing it, then it would use my updated message. Now we already deleted the remote, so let's add that back in. Git remote add origin /server git push origin main. And let's take a look at the commits that happen here. Ooh, we've got a pre-push hook. Very nice. Git pull origin main. We've got some more hooks here. Now we can also put hooks on the server that do really interesting things. If ever you've, for example, done a git push into Netlify or into Azure Web Apps, and then you see a whole lot of messages in your Git history that don't seem to come from you, yeah, that's a hook that they have on the server. So I've crafted these hooks and I've done some really cool things to be able to get these hooks to do awesome stuff. And now I want to commit them. So let me say git add .git /hooks / apply patch message, git status. Nope, we can't commit the hooks because they're inside the .git folder. So there are various programs that we can use. Here's one for Node called Git Hooks that will automatically symlink these hooks into place in another repository. Oh, it looks like I'm not getting history from Git. That's interesting. But we can use other packages, so referencing this history. In Node, there's Git Hooks and Husky. In Python, there's pre-commit, which is also used by other communities, including the C# community. PHP has PHP Git Hooks or Grum PHP. Shell is Git Hooks, or Baziz has a gist for this. Go actually rewrote Git Hooks into Go, which is pretty cool. Or you can create a Git setting pointing your Git Hooks to another directory. Now the hard part is this config is also not committed. So the cool part about a package like this is that it automatically symlinks the .hooks or the hooks folder into a folder that you can commit. In the case of hooks, it's actually the .git hooks folder, which is pretty cool. So at that point, then we can create these hooks and we can share them among our team. That's excellent. So we took a look at the hooks folder. That's really fun. Let's take a look at some config files. Here is an exclude file. We could exclude the node modules folder. If we're in .NET, we could exclude bin obj. If we're in Python, we could exclude the .venv folder. This is a .gitignore file. Now, it is a .gitignore file, but it is inside the .git folder. So I would invite you to not use this and instead use an actual .gitignore. Let's say echo bin to .gitignore, and we'll open that one up inside of VS Code, and we'll put all of our ignore files in here. Now, the beauty of putting them here in this .gitignore file is now we can change them. So let's git add .gitignore, and now we're sharing them with the rest of our team. Perfect. While we're looking at commit files, let's also look at some more config files. Here's the config file. Now, this config file includes all of the things that I set up when I set up this repository, and this overrides the details associated with my user directory. So let's open up cusers rob.git config, and here's the settings that I set. Remember when you said create git config -g user.name? Yep, there's user.name and user.email. You did the -g so that you set it globally in this user-specific config file. Now, I'm not thrilled with that name, global, because it is user-specific, but it is global to all of my repositories, I guess. And this one overrides all of the settings here inside of the git config file that is installed, in my case, inside program files git etc. Now, this one is all of the selections that I made as I ran through the Git wizard. Now that's perfect. I have these settings, it's overridden by these settings, and overridden by these settings. So if I wanted to have this repository only include my work email, but have all the rest of my repositories include my personal email, I can go grab these settings, I can set them in place right here, and instead of this, I will say company.com. There. Now, when I do some commits, let's echo file 8 into file 8.txt, git add file 8, git commit -m file 8, and .git config. Hello. Git log, and now we can see that this one uses my corporate email address, where the other ones used my local email address. Nice. So we've got a few more temp files. We have packed refs, fetch head, orig head. Those are commit messages that are hooks used to be able to communicate. And so we'll just ignore those temp files. But here's one more configuration file. This is the, that sounds great. Here's the description file, and this includes the description that you would use in Git InstaWeb. If you've never used Git InstaWeb, me neither. The last file that we're going to look at is this index file. And yes, it is a binary file, and it's kind of messy. If you want to dig into what it means, here's a Stack Overflow post that goes into the specific syntax of it. But the cool part is we can use Git Ls Files to be able to look through it. Git Ls Files will be able to enumerate all of the files in our checkout directory. Now, this is really helpful because Git doesn't have to traverse through all of these nodes to be able to get at what when it changed last. It can just go find the hash of the file in that directory, and it can compare that to the hash of the file right now, and now it knows if that file has changed. So git diff is really fast. Now we got to look through all of the files here inside this Git folder. Now we didn't run through all the commands, but we did run through all the files, which is really excellent. You can grab the list of, here's one website that kind of reviews each of those files and describes what they do. This can be great review if you want to look through the contents of this talk. All of this is referenced here in this gist, and you can grab this gist from robrich.org, click on presentations, and you can pop open this gist right now. If you're watching this talk later, hit me up on Twitter at rob_rich. For those of you here live at the event, what are your thoughts? What are your questions?